Welcome to Structural Analysis Lectures by Soul Thinking, and today we are going to see another lecture in Trusses. Today's topic is static indeterminacy in Trusses. Before I move on, I suggest you to please watch the video lectures on Trusses in sequence as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the today's class, now we will see about static indeterminacy in trusses. Okay, in trusses. Now in this lecture we will see what is indeterminacy, what is external indeterminacy, and what is internal indeterminacy, what are unknowns in a truss, what are the unknowns in a truss, and how are they interconnected with indeterminacy, how to find the degree of indeterminacy, and then we will solve a problem, a numerical problem on indeterminacy, and we will see when a truss is indeterminate. Okay, when it is indeterminate, how can we convert it into determinate? Okay, we have to do something so that the indeterminate truss will be determinate. Okay, so let's move on in this class. So the first thing we'll see is indeterminacy. Now what is indeterminacy? Now as it is written, static indeterminacy refers to the condition when the external reactions and internal forces in members of a truss cannot be determined alone by the equations of equilibrium. Okay, now let me tell you, when we have a truss, for example, we have a truss like this. Okay, let us say this is a truss. This is one support on the truss, and this is another support on the truss. Okay, now this is a roller support and this is a pin support. Okay, now we know, for example, we want to find this reaction. Okay, let us say this is reaction at A. Okay, this is A and this is B. We need to find reactions at A and reactions at B. Okay, we have to find what is the reaction at A. These are known as support reactions, right? Or we have to find the reaction at B. Or for example, I have told you already, we have forces in these members of the truss. The bars, they contain axial force, right? One member contain one force. Okay, one member contain one axial force, right? So now let us say, assume we have to find the axial force in this. Okay, or axial force in this. Okay, so how are we going to find? We have to apply equations of equilibrium. Okay, equilibrium. Okay, equations of equilibrium. Now what are the equations of equilibrium? They are summation of f of x equal to 0, summation of f of y, forces in the y direction, they are 0, and summation of moment at any point is 0. Now I have already made a video lecture on equations of equilibrium. Okay, static equilibrium. If you don't know about it or you want to know more, please click on the pop-up. Okay, now these are the equations of equilibrium. Okay, now I'm assuming, let us say this is a 2D truss. Okay, this is a two-dimensional truss, and if I need to find the reactions at A, reaction at B, reaction at B, you know, if this truss is in equilibrium, static equilibrium, then I will be able to apply these equations and I will be able to find these unknowns very easy. Okay, now when I talk about this joints, okay, when we have to find the forces in these members, how we do? We find the forces in members using joints. Okay, the pointers. Okay, for example, let us say this is A point, then there are forces here, okay, in all these directions. Okay, this is point A. Because this is only one point, here the equations of equilibrium are only two. because this is a two-dimensional frame. Okay, because this is a point. At a point there are only two equations of equilibrium. Okay, and on a huge body, because when we want to find this support reactions, we will consider this as something, okay, externally. Okay, this will be a huge body. Okay, for example, you have a beam, simply supported beam. Okay, you want to find the reactions at A and reaction at B. Okay, then you don't care what is inside. Okay, you consider it as a whole. Okay, a big body. When we want to find the external reactions, we don't have to care how many are here. We ignore it. We just consider it as a something, one single body with two supports. Okay, and when we talk about a body, the equilibrium of a body as a whole, then we have three equations of equilibrium if we assume the whole body is a 2D structure. Okay, and when it is a point on a 2D structure, then there are only two equations of equilibrium. Whatever, if, now what is indeterminacy? Okay, now if the equations, if these equations of equilibrium, they are enough to find the unknowns, we say the body is determinate. Okay, for example, if we can find the unknowns, okay, let me write, we can find unknowns. What are unknowns in a truss? Unknowns are maybe the support reactions, the member forces. Okay, they are the unknowns. We can find unknowns, okay, with the help of what? Equations of equilibrium. Okay, then we say this structure is what? This structure is determinate. Okay, and if we are not able to find the unknowns with the help of these equations, then we say it is indeterminate. Okay, then we say it is indeterminate. Okay, then we need, of course, when we have an indeterminate structure, we have two ways. Either we can convert it into determinate, okay, or we can use more equations. We will use this equation plus additional equation. We call them as compatibility equations. Okay, we use additional number of equations to find the unknown in indeterminate structures. Okay, now if the truss is determinate, then what? We don't need this compatibility equation. Okay, we only need these equations. Okay, so that's what it is written. Static indeterminacy refers to the condition when the external reactions, these external reactions, uh, and internal forces in members, okay, the forces, the actual force in these members, okay, of a truss cannot be determined alone by the equations of equilibrium. When these equations of equilibrium, they are not enough. Okay, and when that will happen, when they are not enough, the only reason why we cannot do, why a structure becomes indeterminate, is because either we have more unknowns, okay, more unknowns, okay, more unknowns than knowns, okay, then we cannot solve, we cannot, right, we can't, right, if we have more unknowns. So how we get more unknowns? So if we have more support reactions than the, the number of equilibrium equations, or we have more member forces, okay, then the equations of equilibrium, then in that case we will not be able to find the unknowns, and then that truss, that structure is an indeterminate structure. Okay, I will write it more clear here. Let me first erase all of this. Okay, now when we have knowns, when we have unknowns, okay, when they are equal, okay, when knowns are equal to unknowns, okay, we know in mathematics using equations we can, then the structure is determinate, right? When unknowns are less than knowns, tell me, can we find the unknowns with the help of knowns? Yes, because unknowns are less, okay, for example less unknowns and more equations, still then we can find the unknowns. So the structure, the truss is determinate. Now when unknowns, they are more than knowns, okay, for example now the unknowns, for example the support reactions are more than the equations of equilibrium, right? The knowns are equations of equilibrium, right, or the joints. If the unknowns are more than knowns, we cannot find the unknowns, right? Then the structure is indeterminate, okay. So what we need here to find the unknowns, we need more equations, more than equations of equilibrium. They are called as compatibility equations, okay. Of course we need equations of equilibrium, okay, equations of equilibrium, EE means equations of equilibrium. We need equations of equilibrium plus compatibility, okay. Here we only need equations of equilibrium, here also we only need equations of equilibrium. Why? Because they are determinate. When a structure is determinate, you need only equations of equilibrium, okay. And when it is not determinate, in the when it is not determinate means it is indeterminate. Indeterminate means not determinate, okay. Then we need equations of equilibrium plus more equations, we call them as compatibility equations, okay. So I hope you understand this idea. So let's move on. Now we have another concept here. What is external and internal indeterminacy, okay. Now let me draw a truss here. Let me draw a simple truss, okay, like this. Okay, now let's say this is a truss, okay. Now it can be determinate or it can be indeterminate. Now it can be internally means, when I talk about internally, it means we are talking about members, okay, the bars, these bars, okay, members or bars, okay, we are talking about these bars, okay, when we talk about internally. When we talk about externally, okay, externally means we ignore we have anything, we just treat all of this as a something single structure, okay, one entity, okay. We don't care about internal details when we talk about external, okay. Then when we talk about external, the what we have, the supports are related, okay, only the supports are related, okay. Now if we have more number of support reactions, okay, for example if the support reactions are more than the equations of equilibrium, okay, let me write it. When support reactions, they are unknowns, okay, because we don't know the support reaction how much it is. So support reactions, they are unknowns, right? Support reactions, they are unknowns, right? They are more than what? Equations of equilibrium. Equations of equilibrium. Equilibrium, okay. Now when we talk about support reactions, okay, we treat everything as a whole, and this is like something big body, as I have said. Then we consider three equations of equilibrium in case of a 2D truss, okay, 2D structure like 2D truss, okay. The equations are three, okay. When the support reactions are more, we cannot find the unknowns, right? Because the unknowns are more than equations. So how it is possible? So this is known as external indeterminacy. Okay. Now, if support reactions, okay, support reaction, let R be the support reactions, okay. Now, and 3 is the equations, right? Equations. Now, when R is more than 3, it means what? R is more than 3, it is externally indeterminate, okay. Now, when R is less than or equal to 3, now unknowns are less than equations. So, yes, we can find the unknowns. So, it is determinate, okay. But what? Externally determinate. Now, when a beam or a truss is externally determinate, we can find the support reactions very easily, okay. Don't worry, we will solve a numerical problem as we move on. You will understand everything, okay. But just remember, try to understand the fundamentals right now. Now let's talk about internal indeterminacy, okay. You can take a screenshot of this, okay. Let me erase this first. Now let us talk about internal indeterminacy. Rather, it is indeterminacy, right? Anyways, now what is internal indeterminacy? Now when we talk about internal, okay, so we have to go dig deep, okay. So we have to talk about members, okay. Okay, so when the number of members, how many members have we or do we have here? We have, this is 1, right? 1 2 3 4 5 6 7 8 9 10 11, right? We have 11 members, okay. When number of members are more than what? The equations, okay. Let m be the number of members, okay, and they are more than equations, okay. Then what is going to happen when it is more? So it is what? It is internally indeterminate, and when it is equal or less, then it is internally determinate, okay. So that is the concept of internal determinacy and external determinacy, okay. And we don't have any formula for internally indeterminate, okay. We have we will see that later on. You will understand everything. Let us move on first. Okay, now let us talk about degree of indeterminacy in plane or 2D trusses. Now we will talk about how to find the degree of indeterminacy, okay. We are talking about static indeterminacy, right? How do we find the degree of indeterminacy? Now the formula is m plus r minus 2j is degree of indeterminacy. Let me draw a simple truss here. I will show you. Okay, let us say this is a roller here. Let us say this is a pin here. Okay, perfect. Now we have a truss here, okay. Let, how many members do we have? These straight bars, we call them as members, okay. So 1 2 3 4 5 6 7, right? 1 2 3 4 5 6 7, right? Let m be the total number of members, okay. Let r, small r, be the total number of support reactions. Now here, how many support reactions are in a roller? Only one, okay. And how many support reactions are in a pin? 2, right? If you don't know about the number of reactions, you can watch my video lecture on supports and their reactions. Okay, I have already made a video lecture on it. Now, how many reactions we have? 1, 2 and 3. Support reactions are 3. Okay, now how many joints are here? Joints means when you connect two horizontal members, this becomes a joint. Okay, now here we have a joint. This is 1. Let me change the color first. Now this is 1, this is 2, this is 3, this is 4, this is 5, right? So number of joints j are how many? 5, right? Now we have to consider 2j in the formula. Why? Because for each joint, because joint is a point, and for a point, how many equations of static equilibrium are there? For a point, we have only two equations. Summation of forces in one direction in the horizontal direction are 0. Let us say this is x direction and this is y direction. And summation of forces in the x or y direction, they are 0. For a point, we have only two equations of equilibrium. Okay, for a 2D truss. Okay, so how many will be the total number of equations? You see, for one joint we have two equations, right? Two equations. So total number of equations will be 2 multiplied by number of joints, right? Because for each joint there is 2 for this, 2 for this, 2 for this, two equations, two equations, two equations. So the total number of equations are 2 multiplied by number of joints, and number of joints is j. Okay, so 2j is what? Number of equations. Okay, now what are the unknowns here? Unknowns are the number of reactions r. Okay, the unknowns are r, and member forces, they are also unknowns, we don't know them. Okay, in Truss analysis we find the reactions, support reactions, they are unknowns. So r is the total number of reactions, plus what are another unknowns? The member forces. One member have one actual force, so if there are 7 members, so there are 7 unknowns. Okay, so m plus r, m is the total number of members. Okay, now some books also write b. Okay, b plus r. Okay, b or m, it doesn't matter. Now let me assume m. Okay, so total number of unknowns are m plus r, right? Because we only have two unknowns, number of supports and the number of member forces. So the total number of unknowns are what? M plus r. Okay, now total number of equations are 2j. Okay, now when it is equal to 2j, okay, m plus r equal to 2j, right? M plus r equals, then what we have? M plus r, they are unknowns, right? They are unknowns. And number of equations, they are known, right? Why they are known? Because we know for one joint there are two equations, and we know the number of joints very well. So we know the knowns. Okay, that's why we call them as knowns. So when knowns are equal to unknowns, can we find the unknowns? Yes. So when m plus r is 2j, okay, then this, it is determinate. Okay, and when unknowns are more than knowns, we cannot find the unknowns. Okay, when unknowns are more than knowns, in that case we have indeterminacy. Okay, and how much indeterminacy? We will find that with a minus sign. When we subtract knowns from unknowns, it will give us what? It will give us a number, right? And that number will tell us the degree of indeterminacy. For example, unknowns, uk means unknowns are 3, and knowns minus knowns are only 2. Okay, so 3 minus 2 is 1. This number is degree. Okay, degree of indeterminacy. We say the, if some structure have 1 degree of indeterminacy, unknowns minus knowns, how do we find this? We get m plus r minus 2j. Okay, if it is 1, for example, whatever, that is the degree of indeterminacy. Okay, degree of indeterminacy. Okay, so you had to remember this formula, m plus r minus 2j, it gives us the degree of indeterminacy. Okay, I have already explained it. When unknowns are more than 2j, when m plus r is more than 2j, now m plus r is what? Unknowns, right? So unknowns are more than knowns, so statically indeterminate. Okay, now when m plus r is, when these are unknowns, right? When unknowns are less than or equal to knowns, then we have statically determinate. Okay, so, and we have already talked about this external indeterminacy and internal indeterminacy. Okay, so first of all, what we do, let me show it here. uh, we find the total determinacy. Okay, static total determinacy is m plus r minus 2g. Okay, it is, let us say d is a degree of, s is a static. Okay, degree of static indeterminacy, this is the formula. Okay, now degree of external static indeterminacy is what? Let me call this a DE. E for external, it is number of reactions that we have minus 3. Okay, 3 is the number of equations, right? Now when I told you in the external indeterminacy, what we consider everything as a whole like this. Okay, we don't care what is inside. Let us say this is roller, this is pin. Okay, now here we have only one reaction, and in pin we have two reactions. Okay, now for a body, how many are the equations of equilibrium? We have three, right? Summation fx equal to 0, summation of f of y equal to 0, summation of moment equal to 0. So there are three equations, right? When the total number of unknown reactions are more than 3, okay, then we cannot find the reactions, right? So r, let us say this is, here we have 1 2 3, r is 3 here, right? 1 2 3. Okay, now in some cases, let us say for example we have roller on both sides, then we only have one here, and 1 is 2. Okay, so r is the total number of external unknown reactions, minus 3 is the number of static equations of equilibrium. Okay, so r minus 3 will give us degree of external indeterminacy. Okay, now to find the degree of internal indeterminacy, what we do, basically ds is total. Okay, so total static indeterminacy is external indeterminacy plus internal indeterminacy. Okay, so from here we will find the internal indeterminacy as what? ds minus de. So the thing is that the total is this, right? M plus r minus 2j. Okay, this is total. Okay, and external is, external degree of indeterminacy is what? Capital R minus 3. Okay, we are talking about 2D frames. Okay, and the internal is what? Total minus external, right? So that's what is written here. So I hope you understand this. So let's move on. Okay, now we have this problem. In this problem, I hope you can read this text. Let me enlarge the text first. I hope you can read it. Now in this problem, what we have to do, we have to find the static indeterminacy, or it means total indeterminacy. Okay, then we have to find the external indeterminacy of this truss, then we have to find the internal indeterminacy of this truss. Okay, now we both, let us examine these supports. Now this is a pin support, we have two reactions, for a support, right? Here also for a pin support we have two reactions, so here also we have pin, so we have two reactions, right? So the total number of external reactions, right, it is R, okay, or capital R, whatever. It is 1 2 3 4, right? 4. Now we have to find the static indeterminacy. We know static indeterminacy, ds, determinacy static, is m plus r minus 2j. Okay, now m is the number of members, or we also denote m with b, number of bars. Okay, now before I count the number of bars, let me ask you, how many members are here? This and this. Okay, remember there are only two. Okay, it is like this. Let me erase it here and I will show you. One member is like this, and then let me change the color, and another member is like this. Okay, this is not a joint. Okay, this is, they are just, overlapping on one another. Okay, it is basically like this. Let me show you. I hope you'll understand. Okay, this is not a joint basically. Okay, that's what I want to say. Now let us calculate the number of members. M, this is 1 2 3 4 5 6 7 8 9 10, right? We have, let me count it again, 1 2 3 4 5 6 7 and 8. Okay, 8. Let me count again, 1 2 3 4 5 6 7 8 9, and we have 10. So it is 10 are the number of bars or members. Okay, then J is what? Number of joints. Okay, now how many joints we have? 1 2 3. Remember, this is not a joint. Okay, 3 4 5 6. Let me count again, 1 2 3 4 5 6. Okay, J is 6. Okay, so how much it is? M is 10, R is what is 4, J is 6. Now this is 10 plus 4 is how much? 14, minus J is 6, 2 multiplied by 6 is 12. Okay, now 14 minus 12 is 2. So total static indeterminacy is 2. Okay, this is ds is equal to 2. Okay, so let me erase this. Now let us talk about external indeterminacy. Okay, d external, it is r minus 3, right? Total number of unknown external supports minus 3. Now the external supports are 4. It is 4 minus 3 is 1. Okay, so we get de equal to 1. Okay, now we have to find the internal indeterminacy. Okay, di, determinacy internal, it is d static minus de, right? We found ds equal to 2 before, right? So it is 2 and de is 1, right? So 2 minus 1 is 1. I will tell you what it means. Okay, so let me first erase. Now let me tell you. Now the total indeterminacy is 2. Okay, and external indeterminacy, the degree of external indeterminacy is 1, and the degree of internal indeterminacy is also 1. Now from the degree of indeterminacy we found it is not equal to 0 or less than 0. It means this truss is indeterminate, right? This truss is indeterminate. So how can we convert this into determinate? Okay, now this will tell us, the values will tell us everything, the external, internal, okay, whatever. Now we will talk about that. Okay, now how to fix indeterminacy. Okay, how can we convert indeterminate into a determinate truss. How? We can remove what? We'll remove the unknowns. That's it. Okay. By how much? How many unknowns will remove? By the degree of indeterminacy. Okay. Degree of indeterminacy. Okay. So if a truss is externally indeterminate, okay, if it is externally indeterminate, now when we talk about externally determinate, which unknowns are involved in externally indeterminate trusses? The uh, external reactions, right, or the support reactions are involved. When we talk about the external indeterminacy, support reactions are involved. So when, for example, external indeterminacy of a truss is 1, so we will remove how many supports will remove? We will remove one support reaction. Okay. Now, for example, if we have internal indeterminacy. Okay. Now, in internal indeterminacy, what thing is involved? Which unknowns? Members, right? Members M or B, right? As you remember. Now, in internal indeterminacy, members are involved. Now, for example, if a truss have 1 degree of internal indeterminacy, we will remove one member. Why? Because one member have one axial force, so we will remove only one member. Okay, so that the indeterminacy becomes 0, right? Because when we remove one, okay, the members, it will become 0. Similarly, if a structure have external indeterminacy, external static indeterminacy of 1, when we remove one support, we will get 0 external indeterminacy, right? So that way we get a determinate truss. Why? Because for a determinate truss, determinacy is less than or equal to 0. Okay, so let me illustrate this here. Here we have external indeterminacy 1. Okay, so what we do, if we have to convert this into determinate, we will remove any one support. Okay, let's remove this support. So we have only one support reaction, and we know how it is possible when it is a what? When it is a roller. When we have a roller, we only have 1 degree of one reaction, right? So we remove one reaction here. Okay, we will check later if if it becomes okay. Okay, so I know the external determinacy now becomes 0. Okay, so it is externally determinate. Now you can find the unknown support reactions with the help of equations of equilibrium. Okay, we will check this later if it is 0 or not. Now let us remove the any member. Okay, now indeterminacy is 1, so by the logic, theoretically we have to remove one member, then it will become determinate, internally determinate, right? So for example, let me first let me change it to stroke. Now we will remove one member. Okay, let us say we will remove this. Okay, now what we have, we only have what? How many? 9 members now, right? Now we have only 9 members. Okay, so we'll get internal indeterminacy what? 0. Okay, now since external is 0, internal is 0, and we know the total is external plus internal, 0 plus 0 is 0, so we will get ds, total static indeterminacy, is also 0. Okay, now let us see, let's find the static indeterminacy first. Okay, let us say if it is 0, because we fix the things. Okay, now static indeterminacy is m plus r minus 2j. Now how many we have? Number of members, it is 9, and r is the number of reactions, it is 1 2 3, right? 3. And number of joints, how many joints we have now? Number of joints Number of joints are still the same, right? It is 6. Okay, now 9 plus 3 is 12, minus 2 multiplied by 6, right? 2j is 2 multiplied by 6 is 12. So we got 0. Very good. So we found total degree of static indeterminacy is 0. It means we can find the unknowns right now using only equations of static equilibrium. Okay, now let us check external indeterminacy if it is 0 after fix. Okay, now external indeterminacy is number of reactions minus 3 in case of a 2D truss. Okay, now we have how many support reactions we have? 1, 2 and 3. Minus 3 is 0. So very good. Yes, we have static indeterminacy is 0. It means yes, we can find the support reactions with the help of only equations of equilibrium, right? And how much? Now let us calculate the internal indeterminacy is total ds minus de, right? So it is 0 and minus 0 is 0. So yes, the total internal indeterminacy is also 0. So this is how we fix indeterminacy. Okay, either we can fix an indeterminate truss, or what we can do, we don't have to fix, we have to use equations of equilibrium plus compatibility equations. Okay, compatibility equations. If we only have determinate truss, we only need equations of equilibrium, right? We don't need compatibility. Okay, and if we have indeterminate and we don't want to fix it, we want to analyze it, so we need additional number of equations, as I have said before. Okay, so that's it for today. I hope you understand everything. If you have any doubts, please comment, and please don't forget to subscribe. Okay, subscribe and share. Okay, and if you have any questions, you can comment, and you can also email me. My email id is ask.civilthinking@gmail.com. Okay, you can also contact me at this email, or also you can comment. Okay, comment below and I will respond to you. So that's it for today. See you in the next class. Thank you.